Hello everyone, my name is Putu Arindra, and now we will discuss about chapter 12, that is stainless steel, and my main reference is from a book that's called Metalurgi for the Non-Metallurgists, and we next to the chapter 12.1, stainless steel 12.1. The history of stainless steel. The history behind the development of stainless steel is in the early 20th century. It's rich in the art of metallurgy. In 1910, the British journal The Corrosion of Presentation of Iron and Steel published this statement. The tendency to rust is a characteristic in her and the element known as iron, and will in all probability never be totally overcome. It is interesting to note that this statement appeared during the same time period when many of the discoveries that lead to the development of the different classes of stainless steel alloys were actually being made. The alloys collectively known today as stainless steel were developed between 1904 and 1912 by a number of researchers living in France, Germany, the United Kingdom, and the United States. They were all known to each other. Between 1904 and 1906, the French scientist Leon Guillot studied the property of LaCr and alloys. In 1911, German researchers Philip Monars and W. Borsers described the effectivity relationship between chromium content and corrosion resistance in this alloy. 12.2 Modern alloy. Many new stainless steel compositions have been invented and commercialized over the years since the initial discoveries of the alloy were made. One of the reasons for popularity of stainless steel, in addition to their corrosion-resistant property, in their versatility in the processing and application. With some restrictions, stainless steel can be shaped and fabricated by conventional processes such as casting, rolling, and forging. They can also be fabricated using standard powder metallurgy practice. Raw stainless steel can be drawn, bent, formed, extruded, or spun. They can be machined and ground, and they can be joined using standard soldering, brazing, and welding practice. 12.3 Austenitic stainless steel. Austenitic stainless alloys are among the most common grades of stainless steel. They are classified with AC 200 or 300 series designation. The 300 series grade are chromium nickel alloy, and the 200 series represent a set of composition which magnesium and or nitrogen replace some of the nickel. The properties of the 200 series grades may differ appreciably from those of the 300 series, with higher strengths being the most significant difference. In general, the austenitic grades have very high corrosion resistance, excellent styrogenic property, and a good high temperature strength. The process of a center cubic microstructure that is non-magnetic, and they can be easily welded. They generally contain between 16 and 25% of Cr, and can also contain nitrogen in solution, both of which contribute to their relatively high corrosion resistance. They can be easily formed with the same tooling used to process carbon steel, but they can also be made incredibly strong through cold war, achieving yield strengths of over 2000 MPa. 12.4 Ferritic stainless steel. Ferritic stainless steel are relatively low carbon iron chromium alloys classified with IC 400 series designation. They are generally grouped into a low, medium, and high chromium content, with some notable exceptions. They are generally not alloyed with either nickel or nitrogen. The ferritic stainless steel have relatively poor high temperature strength and exhibit limited low temperature and large section thickness. In general, their corrosion resistance is substantially lower than the austenitic stainless steel, but higher than most of the martensitic grades. During the early 20th centuries, the method of steel production that were in use at the time were not capable of sufficient reducing the carbon content of steel to the levels required by many of the today's standards for stainless steel. So additional chromium was used to absorb this extra carbon to produce stainless alloy. 12.5 Duplex stainless steel. Duplex stainless alloys consist of two paste at room temperature, austenite and ferrite. The duplex stainless steel can generally be regarded as chromium molybdenum ferritic stainless steel with sufficient nickel to create a balance of ferrite and austenite at room temperature. The duplex stainless steels were originally developed in the 1920s, but did not gain popularity until recently due to an increased need for stainless steel with improved strength and better resistance to chloride inducted SCC. These alloy process characteristics of both ferritic and austenitic grades. Their corrosion resistance is similar to their austenitic counterparts, but their less corrosion resistance, tensile strength, and yield strength are generally superior to that of the austenitic grades. Toughness and ductility generally fall between those of the austenitic and ferritic grades. 12.6 Martensitic stainless steel. Martensitic stainless steel alloy are FeCrC alloys that are ferromagnetic, and unlike the other grades of stainless steel, they can be hardened through heat treatment in the same manner as non-stainless carbon and low alloy steels. They are somewhat confusingly classified along with the ferritic stainless grade in the IC 400 series designation. The chemical composition for variety of the chromium content in generally in the range of 10.5 to 18% with carbon content spanning a wide range from as low as 0.04% to as high as 1.2%. They are sometimes classified as low carbon and high carbon martensitic stainless steel. The grades processing high carbon level, such as 440 Celsius, are often referred to as stainless steels. The chromium and carbon content are balanced to ensure the formation of the martensitic microstructure. Upon heat treatment, they can also be thermally treated by annealing, stress leveling, and tempering compression. Grades with less than approximately 0.40% C can be surface hardness need treating. 12.7 Precipitation hardening stainless steel. Rock precipitation hardening or PA stainless alloy are designed by the IC 600 series and also by non-standard proprietary composition. However, the UNS designation and the proprietary names of those alloys are often used with greater frequency than the IC designation. Of all the available stainless grades, they generally offer the grades combination of high strength coupled with excellent toughness and corrosion resistance. The PA grades were developed at the beginning of World War II, and unlike the other families of stainless steel, these alloys are grouped as a result of their heat rate response instead of their microstructure characteristic. They develop their high strength and toughness through addition of aluminum, titanium, niobium, vanadium, and or nitrogen, which form coherent intermetallic precipitates during a heat treatment process referred to as heat aging. 12.8 Cast stainless steel. In general, the cast of raw stainless steel process equivalent resistant to corrosive media, and they are frequently used in conjunction with each other. Important differences do exist, however, between some cast stainless steel and their raw counterparts. One significant difference is in the microstructure of cast austenitic stainless steel. There is often a relatively small amount of ferrite present in austenitic stainless steel casting. In contrast to the single-phase austenitic structure of the rogue alloys, the presence of ferrite in the casting is described for facilitating well repair, but the presence of the ferrite also increased resistance to SCC. There have been fewer failures with cast stainless steel in comparison to approximately equivalent rock composition. The powder metallurgy stainless steel 12.9. 3 out of the 5 family of stainless steel, namely austenitic, ferritic, tensitic, and eminently suitable for manufacture via conventional PM processing. Selected alloy from all 5 family can be processed via metal injection molding. The more tensitic grades are used for wear resistant, while alloys from the ferritic austenitic family represent the bulk of PM stainless steel grades. Sintering practice has strong influence and corrosion resistance. Standard PM stainless steel design. In addition to the standard PM stainless grade, a number of non-standard grades are in widespread use throughout the PM industry. In contrast to their raw counterparts, such alloys represent a significant portion of the total number of available PM alloy. This is partly flexible and amenable to the development of custom alloying via sintering or mixture of metal powder. Also, compared to the raw steels industry, the PM industry employs such smaller melting furnace, which make it more amenable to the production of custom design alloy. Okay, that's all from me. If you have a question from this chapter, you can write below in the comment section. Okay, that's all from me. Thank you for watching. Don't forget to like and subscribe. Thank you.